So let's start looking at some of these. So we said that vertical asymptotes are the values that make the function undefined. Our horizontal asymptotes are the y values that the function approaches as x gets really, really big or really, really small. So looking at our first one, okay, this was our 2x plus 1 divided by x plus 1. Where is our asymptote? -1. Are we all able to see that it's at -1? So, like, our x values are getting really, really close to -1. But do we ever actually get to -1? No, because we have a break because our function is undefined there. Now, looking at our horizontal, where does it look like we are getting closer and closer to for our y values?
2.
I agree. Okay. Now, looking at our second graph, okay, how many vertical asymptotes do we have this time? 2. Okay. What's different about this function that might give us 2 vertical asymptotes instead of just 1?
It's on
Square root. Or not square root of whatever that's called.
Yes, a squared. Yeah, this time we have a squared on the bottom. Which, remember, we can factor x squared minus 1. And we would get x plus 1, x minus 1. Which is why, where does it look like we have vertical asymptotes? What? 1 and -1. Okay, this time, though, where is our horizontal asymptote? What are our y values getting closer and closer to? 0. What's different about my second function than my first function? What do we think? We said that the bottom is squared on our second one, so that's what gave us 2 asymptotes. What? The degree. Okay, so our degree is different. On our first one, we had x's where? Top and bottom. Okay, and they were like the same. I had x's, just an x on both of them. On my second one, do I have an x on top? No. Okay. So which other one might we think might look similar to that one? One, 2, 3. Okay, because I have an x squared again. So not quite. This time, where's our x squared though? On top. Okay. Oh, okay. Let's look at that one. Okay, so I have 2 asymptotes again. Where are they this time? The vertical asymptotes look like they're at -2 and not 2 but 3. Yeah. And we also have a horizontal asymptote at 0 again. So this time we do have an x in the top, but is that x bigger or smaller? We have 2 x's on bottom and 1 x on top. So I still have a smaller x on top. Yes? Versus on our first one, we had the same type of x. So what's another one that looks like it's going to have the same type of x on top and bottom? The fourth one? Okay. So our first one we said had a horizontal asymptote at 2. Yeah, the red one. Where's our second one have a horizontal asymptote? Well, I go past 1.5. What does it look like we're getting closer and closer to? What? 1, okay. Where did we get the 2 from on our first one? Or where is there a 2 on our first equation?
Next to x.
Yeah, next to the x on top. Okay. Well, what do I have next to my x's on the fourth one? Sorry, in front. Nothing, right? Which, if I don't have anything, what is that understood to be?
1.
A 1. Okay.
Is this a group project?
No, this is just notes to help you fill in. Because there's a lot of equations and rules and stuff with our rationals. So, I wanted to give you all a place so you could write them out. Alright. So, on the first part, it says rationals. So, a rational function is simply the quotient, which remember also means fraction, of two polynomials. So that's what's going to go in that first space. Okay. Which is why rationals come up in our polynomial unit, is because we're just putting a polynomial on top and bottom now instead. So when we looked at all of these, okay, we kind of decided that our denominators are what looked like they were giving us our vertical asymptotes, which makes sense because if I have y equals f of x divided by g of x, what are we not allowed to have in the bottom? 0. So we get our vertical asymptotes by setting g of x equal to 0. So that's what's going to go on that second blink. Vertical asymptotes are found by setting g of x equal to 0. Now, our horizontal asymptotes, we said, are the y values that the function gets close to as x gets really big or really small. So, and someone brought up that getting really close to stuff sounds like what we talked about when we talked about our limit notation, which is true, okay? So remember with our limit notation, as x approaches positive or negative infinity, so that just means x is getting really, really big or really, really small, okay? F of x divided by g of x is going to be approaching some number. And that value, so y equals L, is the horizontal asymptote. So under limit notation, you can just put that first line. This right here. Because that's what it means to have a horizontal asymptote. Now, finding our horizontal asymptotes is a little bit trickier because remember we were talking about stuff being bigger or smaller. So what we're looking at is the degrees. So on your handout you have a little chart, okay? So n is the degree of the top, d is the degree of the bottom. If n is less than d, so my top is smaller than the bottom, your horizontal asymptote is just at y equals 0. If they are equal, so that's like when we had the 2 and the 1, we just look at the leading coefficients. So that's a divided by b. And if it's bigger, then there is no horizontal asymptote. Again, this is all in that little chart, so you kind of can refer back to it later on. Are we all okay with that? Most of the time we do pretty well with the vertical asymptotes because it's easy to just like see the bottom and solve. The horizontal asymptotes are a little bit trickier. Okay. So let's do a couple of examples of those together. So over on the left-hand side, like where that big space is, you can put down these functions, and we're going to be finding our vertical and horizontal asymptotes. So on our first one, okay, we're going to find our vertical asymptotes first. And remember, we said that our vertical asymptote is where g of x equals 0. And g of x is whatever's on bottom. So in this case, our g of x is x plus 3. So I set that equal to 0. So what do we get for our vertical asymptote? Negative 3. Okay. Then, for our horizontal asymptote, we got to decide which case we're looking at. So if I don't have any x's on top, what's the degree? Not 1, because I would have to have an x in order for there to be a 1. But it would be 0, right? So if the degree of the top is 0 and the degree of the bottom is 1, which one is bigger? 1. So our D is bigger, which means we're looking at case 1. So our horizontal asymptote is y equals 0. What questions do we have on that first one? All right. Looking at the second one. Okay. What are we setting equal to 0 this time? What's our g of x? Yeah, all the stuff on the bottom. What type of function do we have there? Huh? We've looked at a bunch of these this year. What's the degree? Squared, right? And I have 3 terms. So we have a quadratic trinomial. So what do we do with that to solve? That we've looked at all year long. What? Factor it. So what multiplies together to give us 6? That adds together to give us 5. What? 2 and 3. Which is why we got 2 asymptotes on those ones that were squared, because we get 2 solutions when we solve them. So in this case, we get negative 3 and negative 2. Now for our horizontal asymptotes, what's the degree of the top this time? 2. What's the degree of the bottom? Be careful. Remember, the degree is the highest exponent, so what's our degree of the bottom? Also 2. So this time n and d are equal, which, remember, that means that I look at my leading coefficients. So the top leading coefficient is 2. The bottom leading coefficient, if there's not one, is understood to be 1. And 2 divided by 1 gives us 2. Alright. And then lastly, what's our g of x for the last one? So what would we do first to solve? And then? And then? Alright, so we get negative 4/3. Is it okay that we get a fraction? Is that what makes the function undefined? It should, right? Notice if I plugged that in, 3 times negative 4/3 would be negative 4. Negative 4 plus 4 does indeed give us 0, so it would make that fraction undefined. So all that means is that this time, instead of the vertical asymptote being at 1 or at 2, it's going to be in between negative 1 and negative 2, which is fine. So we can get fractions sometimes. Okay, what's our degree of the top this time? So I have x squared minus 3x plus 1. So what's our degree of the top?
Excellent.
The x squared, so 2. And then if I don't have a degree, because I can't see it, but I still have an x, what's our degree of the bottom? 1. So which one's bigger?
2.
The 2. So the top is bigger than the bottom, which means that we have no horizontal asymptote. What questions do we have about finding our vertical and horizontal asymptotes? Like I said, there's kind of, we got to remember a lot. They're not hard, it's just kind of, we got to remember our steps. So that's why you have the handout to kind of help. But tomorrow, we're going to be using our vertical and horizontal asymptotes to graph stuff. So I wanted to make sure we knew how to find them first. All right. That's all we have for today.